In this video, I'm going to explain a program to find the factorial of a number using ARM assembly language program. So you have to open ARM 5 tool. Once you open, you are going to get this window. So you have to create a project. If it's already created, then you can add new source to the group. So add new item to the source group, and you have to select ASM file, and you can give name as, since we are doing factorial number, you can write fact uh, dot as dot s file. All assembly language programs by default it will save as dot s files. So you have to add this, and here you have to type the program for. So first line, there's an option you can give title. TTL means title. So title of the program is program to find the factorial of a number. So after that, this one is actually you can write a comment also. You can write a double slash like this, or you can write a semicolon also, or without semicolon or without double slash. You can write TTL means it's the title of the program. TTL followed by anything is the title of the program. Okay, next area. Its the name is factorial, and it's a code area, and it is read only. So code memory is read only, and export underscore underscore export space you have to give here, underscore underscore main, and is a label. Underscore underscore main is a label, so don't give any space. All the instructions you can see here, blue color keywords are, these are the keywords. You should have to give at least minimum one space. So better you use one tab for that. Labels and variable declaration, you should not give any space. So underscore underscore is a main. Two times underscore you have to write. Shift minus button. So main underscore main. Then move r naught comma 9. So this is the number which we are going to find factorial. So we have to find in this program, we are going to find factorial of a number 9. If you want to find factorial of 5, then you have to change this one to 5. If you want to find the factorial of 4 or 5 or 6, which number you are going to find the factorial, that value you have to give it in the move or not comma that number. We have to save the same number in R1. Okay, then you have to subtract it, because factorial of a 9 is 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 into 1. So we have to decrement every time, and you have to multiply with the previous product. So subtract R1. R1 1 means subtract R1 is the destination, and we are going to subtract 1 from R1 only. Okay, we saved R0 content to R1, we copied the R0 content to R1. After that, we are subtracting, or we are decrementing the value of R0 by R1 by 1. Okay, is equal to R1 is equal to R1 minus 1, and destination is itself it is same as R1 only. After that, we are checking whether R1 becomes 0 or not. See, first time if you decrement R, that is 9 to decrement by 1 means 9 minus 1 is 8. So we are comparing whether R1 value becomes 1 or not. If it is not equal to this one, or if it is not equal to, means if that flag is not equal to 0, then you have to go back. So branch to label stop. Okay, branch if equal the label stop. That means you have to stop. Whenever the R1 value, decrement value of R1 comes to 1, we have to stop. We have to go to the label stop. Else, what you have to do? You have to do mul R0 and R1. So in R0 we have 9. In R1 it is updated with the decrement value of R1. So it is multiplying 9 with 8 now, and the answer is actually stored in R3. Okay, R3 is having R3 is equal to, okay, R0 multiplied by R1. Okay, here next if next again we have to copy the new value of R3, that is product value is actually stored in R3, that we have to store it in R0, and if it is not equal, then branch to label back. So this is a label back. See, once again I will tell you, all the labels you should not give any space. Okay, all the labels you should, and for all the keywords it's coming in blue color, no? You have to give minimum one space. Better you press one tab so that all align in the same here. Okay. So if it is not equal, jump to back. See now, again you have to subtract R1 by 1. Okay, subtract R1 by 1. So R1 is equal to R1 minus 1. Okay. So now from 8 it becomes 8 minus 1 is 7. So that value will be stored again in R1 only. So now we are comparing whether R1 is 1 or not. Now 7 is not equal to 1. So if it is not equal, if it is equal to 1, you have to stop. Otherwise, once again you have to multiply R0 with R0 is where we have R0 a previous product. Okay, we already previously we stored R3 value in R0. So once again we are multiplying previous product multiplied by this R1. Okay, so like that it will continue, and finally R1 will be decremented by 7 minus 1 6, 6 minus 1 is 5, 5 minus 1 is 4, 4 minus 1 is 3, 3 minus 1 is 2, 2 minus 1 is 1. Whenever when R compare R1 comma 1, so when R1 value becomes 1, that time no need to continue the multiplication. It will branch equal, it will go to stop. So in the stop, we have to save the value of factorial into that variable present in the another area we declared here, area result data read write. So result is an one more area, it is a data area, and where we can do read and write. In the code area you cannot write, so it is only read you can do. So if you want to write, you have to declare that variable in read write area, which is data area. So here we declared one variable fact, define constant data, initialize with 0. So you have to place, we have to move that value present in the R3 to this fact location. So you have to get the address here in the stop. Load register R4 is equal to fact means get the address of this fact variable into R4. After that, store R3 value into address specified by R4. So the answer will go to the fact position. So now let us, after typing and saving this program, you save it, then compile it. Okay. So all of you should, when you create a new project and you have to comment these 5 lines for simulation. Line number that is LPC 17xx dot s file. Line number 127, 129, 130. In the beginning, you have to put semicolon, and 272, 273. To compile it. So now you are not getting any errors and warnings. Sometimes you will get some warnings here. If you are getting some warnings, then you have to change here. Go to linker. In the linker, yeah, in the target you have to cite ARM compiler to use default compiler version 5. In the new version, it will be in the 6. You will get some lot of warnings. So change it to default compiler version 5. Okay, now you are not getting any errors and warnings, zero errors and zero warning. Now you have to start debug. So this is a debug button. So it will go to the startup file, load R0 with the address of underscore underscore main. So load R0 is equal to underscore underscore main. It will get the address of this underscore underscore main. In our program, we wrote export underscore underscore main. So it will get that address and it will jump to that. BX means unconditional branch to this location or this address specified by R0. So within 2 steps, so this is step over. Now it is jumping. So it is coming to our program. Within 2 steps, it should come to our program. Otherwise, you have to create one more new project in the new folder. So remember, in a folder only one project should be there. If two, three projects are there, sometimes they get going to get overwritten and you're going to get some error in the compilation. It will not come to your main program. So better maintain only one folder. In that folder, only one project should be there. You can add only files only, not create one more project for another program. Same project, you can remove the file and add another file, and you can continue. Don't create one project for each program. So now move R0 with 9. You can see the registers available in the LPC 176 set. We have R0 to R15. Okay, R0 to R12. All are 32 bits. Stack pointer, link register, and program counter. This is program status register flags. Okay. So now let us execute step by step. Move R0 with 9. See, R0 is loaded with 9. We are copying R0 to R1 also. It is copied now. Now subtract R1 by 1. So R1 is, observe here, 9. 9 becomes 8 now. It is subtracted by 1 time. Now compare R1 with 1. Okay, compare R1 with 1. So 8 is subtracted with 1. So we are comparing 8 and 1. So normally comparison means subtraction will takes place. 8 minus 1 is 7. So Z flag will not set to 1. You can see now. Okay. In comparison, you can see the flag Z flag, it is still 0. If it is not equal, if Z flag is not equal to 1, then if it is equal to 1, then branch equal to stop. Else, you have to multiply R0 and R1. R0 is what? 9. You have to multiply with 8. What is 9 into 8? 9 into 8 is, let us open calc, and you have to open calc, and it should be in hexadecimal mode. So go to programmer, hexadecimal. It is going to 9 multiplied with 8. So you should get 48 in hexadecimal. It is equal to 72 in decimal. Hexadecimal, it is coming 48. So let us see in R3, that value should come 42. Okay. Now it is going to execute this. Okay. Okay. Now you can, now actually the arrow mark is here. Still it is not executed. So previously it is executed branch equal. So since Z flag is not equal to 1, so if it is equal to 1, it is going to stop. Now it is not equal, so it is executing the next instruction. Mal R3, R0, R1. So R0 and R1 will be multiplied, answer will be stored in. So let us see that now. See, 48 is coming. I showed now. Here the calculator, it is 9 into 7 is 9 into 8 is 48, but in decimal is 9 8 is 72, but in hexadecimal, converting 972 in hexadecimal, decimal to hexadecimal, it will give you 48. So 48 is coming here. So that we have to store it in R0. So 9 should be replaced with R0 value. R0 value should be replaced with R3 value. So 48 will be moved to here. After that, again, a branch not equal to back. Okay. You can see that flag is still 0. So it will go back. Again, it will subtract R1 by 1. So R1 is, see how much is there? 8. 8 minus 1 is 7. Now 48 hexadecimal multiplied with 7. Okay. So compare R1 with 1. R1 is 7. 7 is compared with 1. So it is not equal. So if it is equal, stop. Else it will once again multiply R0 with 1. R0 is 48. R1 is 7. So it will multiply those two, and answer will be 1F8. 1F8. You can see here this multiplied with 7. 1 F8 is coming. So 1 F8, again it will be stored in R0, okay, because we are doing move R0 comma R3. After multiplication, we are getting product now, that we have to again store it in R0, so that next time it will multiply R0 with R1. So again, if B and E, since again still also it is that flag is 0 only, so if it is not equal, go back, again subtract 1, 7 minus 1 is 6, again 6 is not equal to 1, once again multiply, so like that it will continue. Okay, I will stop at the last once R1 is equal to 1. Now R1 is 2. Please here R1 is 2 and the previous R0 value is this much 2C40 4C0. So now multiply, okay, store that answer in R0, which is 58980. After that, if it is not equal to 0, go back. Now subtract R1 by 1. So please observe here, R1 is 2, now it became 1. Okay. After comparison, still comparison is not executed, still the mark pointer is showing here. So you can observe Z flag. See, Z flag is highlighted with blue color, it is 1 now. So if it is not equal, it will execute multiplication. Now it is equal, no? If it is equal, 1 is equal to 1 only. We are comparing 1 with 1. R1 value is 1. So if it is equal, we have to stop. So it is now going to stop. And at that time, what is the value in R0? That is the factorial value, because up to there it is actually multiplied and stored the answer here. It is 58980. Now I want to store that. You can see the answer here only. Okay, I can show verify the output here only. If they ask, show me the output in the RAM, you have to store the answer in RAM location. So we have to declare one data area. That is result is the name of that area, and it is a data area, read write area. So fact is a variable declared as defined constant data, and initially it is 0. So we have to get the what is the address of this. So LDR load R4 with address is equal to means address of fact. So we are going to get in R4 that address. Let us execute this. So it is highlighted here. It is 10000. So here you have to open memory window 1, or you can also open like this. If you in the previous program, if it is already opened, it will open immediately. Otherwise, you have to click and you'll get. You can open up to 4 memory windows. So in memory window, you can type here 0x100070. So you can see R4 register is the address. So 1 followed by 70. So in this address by default are zeros. So you have to move this value from R0, you have to move here. So store syntax is store from R3, we have to move it to R4. Okay, in R3 we have 585980, that we have to move it to the address specified by R4. In R4 we have this address, so it will move into this address. See here again 58980. So you can see this is actually hexadecimal only. Okay, I will show both hexadecimal as well as decimal answer. So in the calculator, okay, in the calculator, it is you can see into I think we multiplied 9 into 7 in 9 into 7 in 9 into 8 into 7 into 6, okay, into 5 into 4 into 3 into 2 into 1. So 58980, it is in hexadecimal. In decimal, it is equal to 362 880. That is 3,62,880. So that is the decimal answer. In the memory also, here also you can change the data value to decimal. You can get the same answer as 3,62,880. Okay, this is the decimal. If you don't want decimal, hexadecimal, this is the answer. So you are getting the answer of factorial of a number. Okay, thank you.